Well, welcome. Thank you for joining us. Welcome to the Google Cloud Innovators Live. My name is Amir Abbas. I'm a product manager at Google. I'll be hosting this week's Cloud Innovators for you. I work on application modernization. I also have the privilege of being on the Istio steering committee. I've been actually doing Istio pretty much since its inception. Proud to say that we just celebrated our 5th anniversary. I think when a project hits 5 years, like it's here to stay. So we're very proud of what we've done. Some of you might already be using Istio, so thank you for using that. Today, we're going to really just kind of talk about, what is the mesh doing for application modernization, how Istio is built, and most importantly, kind of what is the value of managed Anthos Service Mesh, which is based on the Istio APIs on top of running your own Istio. So let's get into it. So these are some of the things we're going to talk about. So right off the bat, when we talk about mesh, we think about features of the mesh, right? We talk about security and observability and traffic management, and those are just the features. I really try to rally around the service, and there are 4 things that every service needs. Your services need to be reliable, they need to be scalable, you need to have a platform to be able to provide policies and provide security to your services. And to me, the most important thing is your services need to be manageable. And a lot of the times we actually interchange the word service mesh with service management, and I think that's rightfully done. So some of the quick definitions of these, I think reliability is very simple. We want to only affect part of the service when something bad happens, whether it's a human error or whether it's some sort of a geographical problem or a machine error or even a code error. We only want to be affecting a small percentage of that thing. And mesh really helps you with that. I think this is one of those unsung sort of tenets of the service mesh. Scalable is pretty self-explanatory. You want to be able to run your services in more zones, in more regions, in more computers, in more clusters, and so on and so forth. And you want to also be able to run more services in general. You want to be able to have a platform where you can create policies, but also enforce policies. You want to be able to do things like authentication and authorization, encrypt all traffic between all services. These sort of kind of cosmic rules that you have to implement zero trust network. You want to be able to do that. And then, like I said, the last thing to me, which is service management, is kind of the biggest thing. And I think the other 3 kind of get consumed into that. Somebody smart once said, you cannot manage what you can't observe. So telemetry, observability kind of falls into that. And as you're iterating on your applications, how do you manage not just 1 service or 10 services, but hundreds or thousands of services? And how do we do that, right? So these are the kind of the 4 things why you really kind of need the mesh. Just to quickly define what a service is, in my very simple definition, a service is just a collection of endpoints that run on multitudes of runtimes. The most common ones are here. So you can either run your services on Kubernetes, that's kind of the hot ticket right now, on VMs or bare metals, or even serverless. And you might have services running on kind of all 3 of these. You might be kind of moving from VMs to Kubernetes, and you're testing out the serverless thing. And there are certain functions that every single service needs. And we talked about a few of those, right? Services need to be able to discover each other. They need to be able to discover kind of the healthy parts of other services. They need to be able to connect to each other securely, authenticate, authorize. You need to be able to observe those services. And like I mentioned, you need to be able to kind of put guardrails around these services. Now, if you start doing that at a per service level, so what that means is that when a new service comes about, you have to start thinking in terms of all of these things. And especially if you're running in these kind of dynamic, heterogeneous sort of environments, it becomes an operational challenge. So a service mesh architecture pattern essentially just says that your platform should be able to provide all of these functionalities as part of the platform, not as part of the service. And you can now just use these functions as your service. It's almost like having extra knobs in your switchboard. All of these functions is sometimes we call them application network functions because these are not really business logic. And what that allows you to do is, as a platform administrator or as a service operator, I can just focus on these application network functions and let my developers focus on the business logic. So I look at service mesh as an architecture pattern that just says that all the application networks need to be part of the platform and not part of the service. So how do we accomplish that? So like many other things, service mesh also has a concept of a control plane. And the control plane's primary job is to discover all of the services, regardless of where they're running, regardless of which runtime, or even in which environment, in which infrastructure they're running, and configure the data plane so the services can discover each other. And in addition, it can also do health checking. Then you have something called the data plane. The data plane's job is the actual traffic plane. So how do requests get from service A to service B between, again, runtimes and so on and so forth. And then there's a third component of service mesh, which I just collectively, I call that mesh services. And these are things like identity, security, policy management, telemetry, all of those things kind of combine. How do you augment the mesh in certain form or fashion. So these are collectively, these things provide you with this application network function. So enter Istio. The implementation of Istio is very similar to what we just kind of talked about. So there are three components. In the middle, you have the control plane. So the control plane is what you as a human or a CI/CD system kind of interface with. The control plane talks to the data plane. I divide the data plane into two components. You have your workload proxies and the workloads, how you talk between workloads. So that's done by kind of the workload proxy that's on the left-hand side. And then you have gateway proxies, which are, again, no different than the workload proxies. The only difference is that they perform a different function. They sit on the periphery of the mesh. So between the mesh, you use the workload proxies. From the mesh or to the mesh from the outside, or if you're sending traffic from the inside the mesh to the outside, you use these gateway proxies. So the common ones are, of course, ingress, when some request needs to come in from the outside to inside the mesh, or egress, when a request needs to go from the inside to outside of the mesh. And then at the top, you have these mesh services. So things like certificate authority. In Istio, every single service has what we call a strong identity that's provided by a certificate authority. With that, you can also provide certificates to do authentication and authorization. All the telemetry dashboards. So you have traffic logs, access logs, as well as tracing and topology graphs. And then you can have other things that you might want to use to augment the mesh. So a very common one is policy controller, if you're using something like an OPA or an open policy agent gatekeeper. How do you use some security functions that's provided by the service mesh and put guardrails around that, right? So with Istio, the implementation of all of these three things, they run inside of the Kubernetes cluster. So you have the control plane running inside the cluster, your data planes running inside the cluster, and all of these services, your certificate authorities running inside the cluster, and everything else too. And with that comes challenges of managing the lifecycle of these pieces. And I'll give you a quick trivia. We did a recent survey of our Istio implementation kind of across the board. This is open source Istio implementation, just to see kind of how many people are keeping up with CVE patches or keeping up with upgrades. And we were very surprised that it was over 80% of the people are either running a known vulnerability version or they're running a version that is just simply not supported, right? So what we realize is that, maintaining Istio is a complex challenge. Once it's working, it's human nature to just kind of leave it be. But, just like every other open source project, every quarter we release a new version, and then every third version gets out of date, and we don't perform any kind of CVE patches on top of that. So when you look at a picture like this with a lot of components running, and you think about like every 3 months I have to do a minor upgrade, and then perhaps every month I have to do some sort of a CVE patch, it becomes operationally a little bit more complex. So this is where managed Anthos Service Mesh comes in. So what we're doing is we're taking all the boring bits out of Istio. We simply want you to just consume Istio, right? And so this is the same picture. So the first thing we did is we removed everything that kind of augments the mesh, so all the mesh services. So certificate authority is fully managed. It runs in Google infrastructure, and you just simply consume that thing. And we have actually a couple of different options for certificate authorities. Telemetry dashboards. This is something I'm going to show, hopefully, if we have time, on kind of what you get out of the box and how do you actually manage a service. So that's the hopefully I'll show a little bit of that. Again, you don't have to think about putting things like Prometheus and Grafana and Kiali and Jaeger. All of that is now inside of the consoles. So where you manage your clusters, now you can also manage your services. And then we'll also talk about kind of how you integrate things like policy controller and so on. The next thing we did is we removed the control plane. So a control plane in Istio is an Istio-D. It's a workload and a service that runs inside the Istio system namespace, again, inside of your cluster. That now runs outside of the cluster in Google infrastructure, and it connects securely to the traffic plane. And then we manage that for you. And what that allows us to do is it allows us to manage the upgrades and the life cycle of it. So I tell people, when you go to manage the ASM, that's the last upgrade you'll ever do. You'll never have to upgrade the control plane or the data plane. And then the last thing, I know this picture is a little dramatic, which makes it look like we're yanking the data plane also out of the cluster. The data plane remains inside the cluster for obvious reasons, for performance and security reasons, but we've taken all the management out of the cluster. So as the control plane gets upgraded, we have a subcontroller that monitors the versions of the data plane and all the proxies, and we roll out the proxies safely kind of on your behalf too. So again, if you just draw the line and you just think about like all the value that you want to provide, so things like reliable services, scalable services, services that are managed by policies, and services that are manageable in general, those things remain. So all the APIs remain, and that's how you consume that mesh. but anything to do with the management of the mesh pieces themselves have been removed. So hopefully you can kind of start to visualize some of the benefits of this. So that's Google Anthos Service Mesh. It becomes part of the platform. At the very top, you have services that are represented by these circles. Now, the reason I always represent the service separate from the workloads are the squares that are at the bottom, is because the workloads are highly dynamic. You're either migrating services. In some cases, you might be running in hybrid sort of runtimes where, let's say, you're migrating something from VMs to Kubernetes, and the service might be running in two different environments. You might be scaling a service. You might be upgrading a cluster. So the workloads are highly dynamic, but the idea is that the service remains kind of consistent. And if we can provide these functions at the service level, that's what we really want to do, right? We don't want to manage workloads. We want to manage services. So things like between service A and B, I want all traffic to be encrypted, or perhaps between all services. I want to be able to provide that function at a service level, right? Same thing for authorization. I just want these services to have authorization policies across it, regardless of what the workloads are doing. And especially as you get into distributed systems and as you get into Kubernetes and then multi-cluster Kubernetes and maybe even hybrid or multi-cloud Kubernetes, managing workloads becomes very, very painful. So I'll end with this, and then I do want to kind of show a little bit of how I manage services, and maybe it gives you a little bit of an idea of what the product can do, but also kind of a day in the life of a service operator. So there are three benefits, in my opinion, of ASM, and they are starting with support, which I think is kind of the lowest benefit. So one of the challenges with Istio is that it's an open source project. So if you're running Istio open source in production, anytime there's a challenge, it's kind of up to you or up to the community to get that help, and you're kind of on your own. So ASM, or managed ASM, you can think of it as it just provides you Google kind of first-party support for your Istio implementation. All of your Istio configuration and APIs can migrate or port over to managed ASM, so it's a very, very easy port. Again, we're going to stay as clear, as near and dear from an implementation perspective to Istio, right? So I kind of give the analogy of what GKE is to open source Kubernetes is what managed ASM is to open source Istio. We also not just support things on Google Cloud. We have managed ASM support for non-Google Cloud environments. So Google Distributed Cloud, so that's your edge locations and remote locations. Hybrid Cloud for your Anthos on-prem clusters, as well as multi-cloud for Anthos on AWS, Anthos on Azure. We also support Anthos attached clusters. So these are third-party clusters that you have registered to Anthos, right? In addition to kind of these hybrid infrastructure environments, we also support multiple runtimes. So obviously Kubernetes. We also support GCE VMs, VMware, as well as we're looking at supporting serverless very, very soon. So that to me, like I said, that to me is kind of the lowest layer of value, which is just the idea of just providing support for Istio kind of across a breadth of different environments and runtimes. The next one is the idea of it being truly a managed service. And this is where kind of the implementation of ASM and Istio start to diverge, not the consumption. The consumption remains the same. So things like managed control plane, managed data plane, managed CA service, policy controller, these are all Google managed services. Managed control plane, CA, telemetry dashboards, which I'm going to show you, they don't even run inside of the cluster. So we're trying to pull as many things out of the cluster and put it in Google infrastructure and have an API that you can use. You can put IAM around it, and you can simply consume that. And that obviously rids you of any of the lifecycle management, any of the CVE patches. We ensure based on your signals, kind of what version they need to be on. So that's, to me, is kind of the one layer above, is you get a supported implementation of Istio, but you also get a managed experience. So you don't have to worry about things running inside of the cluster. And then the last one, which I think is kind of the highest tier of value of Istio, is what I'm going to show you a little bit, is some of these enterprise grade features. So you have these kind of mechanical functions that, all the application network functions that Service Mesh provides and Istio provides and managed ASM provides. But how do you now utilize all of these signals into actually managing your applications? So things like integrated dashboards. So whether you're doing metrics, logging, tracing, or topology, all of those are now kind of baked in. We kind of give you kind of a bird's eye view of what your service is doing and then how you troubleshoot that. Security insights. So are you actually running a zero trust network? That's a completely different talk, and maybe I'll talk about that. But the idea is that I want to go to one screen and I want to be able to see kind of what the security posture of my, of my service mesh is. We're also integrating with other APIs. So Gateway API integration is very, very exciting for us. So Gateway API is kind of the successor to the Kubernetes Ingress API. You may have heard of it. If you haven't, I highly encourage you go take a look at it. They're doing amazing things. And what that allows you to do is, even if you're a non-mesh expert, you just want to be able to consume certain features of the mesh, now you can use native Kubernetes API like Gateway APIs to be able to provide essentially a mesh, mesh connectivity. We have other features. I don't need to go through every single one of these, like IDP, which is the bringing your own third-party identity provider to talk to web services that are running there. Like I mentioned, we are in preview for Cloud Run, which is our serverless platform, Cloud Run support. So if you have services running in Cloud Run and Kubernetes and VMs, and you want to basically create a mesh across all of these, you can do that. And then I'm personally working very, very closely with the Apigee team. Apigee is our API management, L7 API management platform. And how do we integrate the L7 mesh to the L7 API management to give kind of that full end-to-end developer experience? So this is kind of where the product is headed. All right, so let's get into the demo. Oh, by the way, I forgot to mention, if you have any questions, please use the ask a question or the chat feature, and one of our moderators will either answer that or I will get to all of the questions at the end. I'll have a list of all the questions and I'll try to answer as many as you can. So as I'm talking, and if you got questions coming up, whether it's about the program or whether it's about this presentation, please feel free to ask. All right, so let's switch to the demo. So I'm gonna pretend that I'm a service operator, and my job is to keep this particular application alive. Some of you may have seen this application. This is the proverbial online boutique or the hipster shop application. It's a simulated application that's simulating an e-commerce, sort of an e-retail application. I always start with the application because I think it grounds us, right? So I think we need to focus on the fact that all of us kind of sort of exist to keep this application alive and delightful and running. So this particular application, as you can see, it has a front end and it's showing me some products and stuff. And I can click on these products. So I can click on sunglasses, for example, and I can get more details about the product. I can add this product to a shopping cart. So it has a cart feature. I'm using Redis to put all the cart items. I also get some recommendation based on what I've placed in the cart. So I can go into other products, add these to carts, and all my cart items remain. Now, another thing you may have noticed is this banner on the top left-hand side. It used to say Google Cloud, and now it's saying on-prem. As a matter of fact, if I just kind of navigate through this application, you'll notice that it'll bounce back and forth between Google Cloud and on-prem. So what does that mean? So first of all, this is just for the demo purpose. So if I'm just a user of this application, I won't see that banner, and I can just continue basically shopping on this application, right? I can just add items to my thing. I can place order. I'm just going to click on this really fast. What this banner is telling you is whether this particular front end is being served out of Google Cloud or it's being served from an on-prem environment, right? So that's kind of the first thing I wanted to show on Service Mesh, which is the fact that I can stitch services together regardless of the infrastructure, regardless of the environment. That's one of the first things you need, right? So let's say you're migrating from an on-prem environment to Google Cloud. How would you do that? Well, you'll probably first go to in some sort of a hybrid scenario or migrating one service at a time. So you need services to discover and talk to each other across these environments. And for the sake of the demo, I have front end running in both environments. So the front end is my hybrid service, and I'm just doing a round robin, load balance between the front end and the on-prem environments, right? So I have Kubernetes clusters running on-prem in Anthos on bare metal clusters, and I have front end running there, and then I have GKE clusters running in GCP. And so let's go in. I'm a service operator, and first things first, I want to make sure that everything is good, everything is healthy and happy. So you can see that I have a bunch of clusters. So I'm in the Google Cloud Console. I'm in the Kubernetes clusters page. If you have not seen that page, this basically tells you how your Kubernetes environment is doing, and this tells you your Kubernetes environment across different infrastructure environments as well. So these top 4 clusters, for example, are GKE clusters. They're running in GCP. And then these bottom 2 clusters are Anthos on bare metal clusters, and they are external clusters that I've registered to my project, and they collectively form what we call a fleet or an environment. So you can think of it as that all of these clusters represent my production environment. This is where I run my services. As a matter of fact, this is where I was running that application that I showed you. On the left-hand side, I'm going to go to workloads. So I want to see kind of where all the services are running. I've already filtered this by just the shop application. So that was the application that you were running. And so a few things kind of come to mind. One is that the application is composed of multiple microservices. As a matter of fact, it's 13 microservices. Each of these services is running in their own namespace. But you'll also notice that each of these services is running on more than one clusters. So if we look at the far right-hand side, you'll see the clusters. So for example, the ad service is running, there are 4 workloads running in each of the 4 GKE clusters and so on. So car service, checkout service, currency, email, payment. And if we go down all the way to shop front end, you'll notice that the front end is running on 2 GKE clusters and 2 Anthos on bare metal clusters. That's why you were seeing it kind of go back and forth between GKE or between Google Cloud and on-prem. So this is highlighting the idea of service discovery across clusters as well as across environments, right? So basically, as a service operator, I just need to be able to place my workloads where they make sense. And I need the platform to be able to discover the services, make sure they're healthy, and route to each of the services using the Kubernetes naming scheme, right? So for example, when the shop front end wants to talk to the recommendation service, it can just go and communicate with the recommendation service, and it just simply works. It's really hard to demo that, so I'm just kind of talking through that, right? So up till now, what you're seeing is a very infrastructure-centric view, right? So I'm in the cluster view, I'm in the workloads view, but it's also showing me a very cluster-centric view. That's great for a platform administrator or for a Kubernetes administrator that's monitoring kind of clusters. What I really want to see as a service operator is a service-centric view. And this is where kind of the value of Anthos Service Mesh comes in. So I'm going to go to the hamburger menu, go to Anthos and Service Mesh. So everything, first you'll notice that everything, I never left the console, and that's kind of a key idea behind a user experience, is to just make sure that you don't have multitudes of tools that are open unless you need them, which makes sense. But for now, I want to be able to very quickly identify if there's a problem with one of my services and where the problem is. So at this point, I'm a service operator. I'm not a Kubernetes admin. My job is to keep services healthy and alive. My job is not to keep Kubernetes clusters and upgrade the clusters and so on and so forth. So here, the first thing you'll notice that I get a service-centric view. And how do you know that? Well, I always look at the first column. And so what is the first column? It's the service name. It's no longer the cluster name or the Kubernetes name, right? So as a service operator, I just want to see my services first. And yes, maybe I am interested in which clusters they're running in, and that this table does show me that, right? So for example, this accounts DB is running on these 4 clusters, right? So eventually I want to see where my services are running. For example, this shop front end was initially running on 6 clusters. I just moved it to 2 or 4 clusters right before this demo. So this is a table view. This is a very common view for a service operator. You may also want to look at a topology view. So if you're used to Istio, you would get that table view from something like a Prometheus and a Grafana, and you would get this topology view from using something like a Kiali. So again, I'm not leaving the console, and I can get a very similar experience without implementing anything else. So this kind of tells me that I come in through the ASM ingress gateway, I go to the shop front end, and then from shop front end, I talk to a bunch of different services, but eventually checkout, and then checkout talks to all these services. Right? So this kind of gives you a bird's eye view of where everything is. You can also just click on any of these and expand and get a lot more detail. So for example, I expanded the shop front end, and I can see the deployments. So I've got 2 deployments running on GKE, and then these 2 deployments are running are on-prem. I can also change the time span. So this is giving me kind of a snapshot of the last hour. But if I want to see kind of how things have changed in the last month, I can switch this to last month. Although probably nothing has changed. But let's say you are adding new services. You can just scroll back in this timeline at the bottom, and you can kind of see how your services have evolved and how you've added new services to this. You can do kind of the same thing with the table view as well. Okay, so what do we do with this information? This is fine, but how does a service operator actually troubleshoot something? So I can come to this particular screen, and I can just kind of see that all my services, they're healthy or not healthy. But I'm really interested in anything actionable. Do I need to perform any action? Is there a service that's not healthy? And right off the bat, right away, I just want to see kind of a card that just says, 3 services are unhealthy, or 1 service in this particular case should be checked. Even though I have 43 services total, I don't really need to sift through all 43 to figure out what's going on. So I can filter by these services. So I just clicked on this filter services, and it's just going to show me the ones that are actionable, the ones that I need to take some action on. And so right away, I can see that shop front end has this warning sign. And if I hover over that warning sign, it says something like services have exceeded their error budget, whatever that means, or SLOs. Okay, so let's click on this service. So when I click on this service, it gives me a very service-centric view. Now, one of the things with managed ASM is that you don't have to do a lot of instrumentation to the service. There's only one thing that I instrumented in the service to get some additional telemetry, but everything else is absolutely no instrumentation to the services. This is just out of the box that you get with the Service Mesh product here. So now I'm getting a contextual view of just the shop front end. Now I'm in just the shop front end. And right off the bat, again, even in the shop front end, I want to see kind of what's going wrong. What do I need to actually take action on? I don't need to see, all the extraneous information. So that's right up front. So right up front, I can see that I have two SLOs, which stands for service level objective. And SLO is a way to really kind of quantifiably measure the health of a service. I'll show you what those are. And one of them is out of error budget. So let's go into that. So I'm going to go to see SLO details. Now, if you don't get anything out of this presentation, remember this screen, that for every single service, you can create one or more SLOs. And like I said, SLO is the most non-controversial way to measure the health of a service, right? So there's no more controversy. It's all mathematically done. It's all statistically done. And you can use any of the custom metrics or any of the standard metrics. So I have two SLOs here, these two rows. So the bottom one is availability, the top one is latency. For any kind of web services, I tell people this is probably a pretty good place to start, is have one for availability, which is pretty self-explanatory. If I click on that, I can open this. And the availability one just says, the way to read this title is, I want this service to be available 99.9% of the time in a calendar day, right? So in 24 hours, I want the availability to be 99.9 or higher. And so we can see that everything is green here. The service level indicator tells me what it is right now. So right now I'm at 100%. There's actually two lines here that are superimposed on each other, so they're very hard to see. But there's a dotted red line, which tells me my goal. And then there's the blue line, which tells me the actual thing. When I show you the latency one, it'll become very, very clear. So great, my service level indicator is good. It's above my SLO. So my SLI is above my SLO, I'm healthy. The next thing it calculates is something called an error budget. Error budgets is a statistically calculated value. This is where innovation happens. This is the leeway for you to iterate upon this application. So for example, if you want this application to be available 3 nines or 99.9% of the time, which amounts to about 40 minutes worth of, let's say, outage in a month, that means you have 40 minutes to make changes to this particular application every month. And this is great because you want to be able to make changes to this application. But now you can do it very mathematically in a very measurable way. So this is the error budget. It's above 0, so that's good. And then you can also set alerts. And alerts would be that, when the error budget starts to burn a lot faster, let's say. Obviously you want to get alerted when you've completely blown through your SLO, but perhaps you also want to get alerted before you blow through that. So that's another value of having an error budget, is how fast are you burning through that error budget? Sometimes we call that the burn rate. Am I burning too fast and I'm tending towards breaking the SLO? And so you can set alerts based on, something called a look back period. Hey, in the last hour, I'm burning, 2x faster than I normally burn, right? Or in the last month, my error budget is burning a lot faster, right? So you create averages or means, and then you figure out what kind of the rate of burn of the error budget is. So those are some of the concepts. Again, no instrumentation required to the application. This latency one is out of error budget. So let's open this one. So this one is where you can see the two lines very, very clearly. So you have this dotted red line, that's my goal. So what is my goal? So if we read this, it's a little bit harder to read. Basically what I'm saying is that 90% of all requests in a calendar day needs to be faster. The response time needs to be faster than half a second. That's basically my SLO. That's how I determine that this application or this service, shop front end, is healthy. The blue line is what's actually happening. So you can see kind of, just if you kind of look at this left-hand side, I think I just, let me go back to an hour. Okay, so you can see that we're at about 40%, right? Which you can also read up here. So the service level indicator tells you what it is right now. It's below the 90%, which is my goal. It's below the red line. And that's why I have a negative error budget. And so what a negative error budget means is that it's like stopping the assembly line. So let's say you had an assembly line, of your CI/CD changes, you're iterating upon this application and you're making changes to this application. Something bad has happened. You are no longer compliant with your SLO. At this point, this service is considered unhealthy, and you stop the assembly line. That means you are no longer iterating, which means you are no longer innovating. Again, a very, very powerful tool to have this SLO in there. So I can see that something's going on with this SLO. It's not meeting my SLO. So how do I troubleshoot this? Where do I go from there? So I'm going to go into this left-hand side menu. I'm going to go to metrics. These metrics, again, come out of the box. These are what we call standard metrics, or sometimes they're also called the SRE golden signals. Again, for every kind of web service, you want something like requests per second. I call this the heartbeat of your service. If you're expecting this service to be utilized, hopefully there's something happening, right? And if you know your service, then you can see that, yeah, for this time, I'm seeing about 23 requests per second. That sounds about right. If we scroll down, I can get error rates, both for server error rates as well as client. So I want to see error rates. So that is what is not working, where the first one is kind of how many requests are successful. These two are how many requests are non-successful. The next one is latency. This is the one I'm interested in, right? And this latency is divided into these 3 percentiles, right? So your 50th percentile, which is the blue line. The middle one is 90th percentile, the orange line. And this top one is also orange, but I guess it's the lighter orange, which is the 99th percentile. And you can see that the 90th percentile is right around a second and a half. So 90th percentile latency for all server requests. You also get some of the other ones, so request size, response size, CPU, and memory. For every single service. I did not create these dashboards. When you click on a service and you just click on metrics, you will start to get these metrics right off the bat. I did not instrument anything. I just simply enabled managed ASM. I started deploying my services. I came to this screen, and that's how quick this is. Okay, so I can see that the latency is high, but what is causing that latency? So if I go to this, at the very top, you'll see something like view traffic logs. I'm going to click on that, and that's going to open a new screen. And then it's going to filter that by just the traffic logs. You can think of traffic logs as your access logs. So these are the requests and the response. So this is now filtered by just the front end, just that particular service for the past hour, I believe. Yep, looks like it's about the past hour. And I like reading this because it's very readable. So where the first metric is just verifying that the latency is high. Now I want to see kind of, well, why is the latency high? Where do I see some of these latency high? So here I can see different columns. So I can see the method, the response size, and the latency. That's the one that I'm really interested in. And this last one, which is the actual call. Where was the call made? So here I can just kind of eyeball it. So I can just look at some of the really kind of highly latent ones. So this one, for example, took 947 milliseconds. And I can just kind of take account of this particular endpoint. So whenever it goes to this one, it's higher. Here's another one, again, product. So it's getting some product detail from a database. So that's where it's slow. If we go down to this one took over a second, 1.3 seconds. It's the cart. It's doing a get cart probably. Yep, it looks like it's a get cart. So when it's trying to get the cart details, that took over a second. So again, that's talking to a database. Same thing down here, 900 milliseconds. So now I'm starting to kind of hone down that it might be a database latency issue. If we go back to this screen, I can look at application logs. I'm going to ignore that for now. This really has nothing to do with Service Mesh. That's just the typical application logs. But I want to go to view traces. So if I click on view traces, it's going to show me traces for that particular service. Once again, I'm staying within the console, right? So I did not install anything else. I'm going to get rid of all these filters. If you have not seen a trace before, the way the trace is read is you have the x-axis is the time. So again, it's showing me kind of the last hour. I can change this time to 6 hours or a day or whatever you want, and that'll show you that. And then the y-axis is the latency. And each dot represents one full request. And remember, a request traverses many services. So here I just want to see, per request, I want to see the latency. And I can click on some of these highly latent ones. So for example, this one took over 2 seconds. If I click on that dot, which represents one request, I can scroll down and I can see that service chain. How did that request traverse different microservices? So the top line is showing you the full end-to-end request. So that took over 2 seconds. And then individual lines down here are showing request. So that took over 2 seconds. And then individual lines down here are showing you kind of calls between services or even between API calls between functions. And you can kind of see, you can eyeball it that out of the 2.1 seconds, 1.2 seconds was just get cart, which is the database, which is the Redis database. I can scroll up and just click on a different one. So here I'll click on this one. That one took about the same thing. So 2.2 seconds total time, and the get cart took 1.2 seconds. So you kind of get the point. So like this is the way I use tracing is if it is a latency issue, I'll come here and I'll just click on some of these higher ones. So at this point, I've started with the metrics. The metrics just prove, well, I started with the SLOs. The SLOs, I didn't even have to do anything. I got alerted, either paged, emailed, slacked. There's a billion ways to get paged. From that, I ensured that I am indeed in violation of my SLO for my latency-based one. So I knew that something is happening with latency. Metrics confirmed that, yes, the latency is high. Then I went into traffic logs just to kind of get a ballpark idea of kind of, which particular calls are highly latent. And I started honing into some of the databases. And then I looked at the traces and the traces just to kind of see that is there other latencies too, or is it just happening on one of these calls? And you can kind of see from this one too, is that all the other calls are very, very fast, right? So 37 milliseconds, they're fast comparatively speaking. And then this one took almost a second, right? So the get card. So at this point, I've at least identified, as a service operator, I've identified that the card service is slow. Now I can open a ticket and I can say, let's talk to the Redis database or the networking group, depending upon where the problem is. So up till now, no instrumentation to the application except for tracing. Tracing is the only thing where I did instrument the application with the OpenCensus service agent. And the reason you need that is because for traces, you need to be able to traverse the span ID for every single request, across different services. And this is how the tracer stitches that request together. So that's the only instrumentation. The SLOs, no instrumentation. The metrics, no instrumentation. Even the access logs, no instrumentation. Tracing is the only thing. And if you don't have this instrumentation, you would have eventually gotten to this conclusion by just looking at the logs as well. All right. So as a service operator, I kind of went through that slowly just so I can kind of show you that. But again, I would probably go through this a lot faster. You may start with tracing, you may start with logs. I just wanted to kind of show you, a kind of a product walkthrough and show you what everything is there. The last thing I'll show you is that, well, you can say, well, that's fine. It looks like there's something happening with the database calls, but is it happening on one cluster or multiple clusters? How do I, maybe one cluster is really slow and that's why, 90th percentile is not hitting. Again, if we go back to the Anthos Service Mesh page, we were on metrics. I'm going to go to infrastructure. And what infrastructure does is it gives you the same metric chart broken down by your infrastructure. So remember, shop front end is running on 4 clusters. If we scroll down, you can see these 4 clusters. The top 2 that have the location of global are my on-prem clusters, and the bottom 2 are my GKE clusters. Here are the 4 lines, and you can kind of see that there's no kind of sort of difference. I can also get a lot more detailed. If there was a problem here, for example, let's say one of them was flatlining or one of them the latency was really high, then I can just click on it right here and I can tell exactly which cluster it's running on, which node it's running on. I can even view the YAML if I needed to, right? So there's a way to kind of eliminate whether it's a networking issue or whether it is a service issue. In this particular case, I'm fairly certain that it is a Redis issue. And this was a true story, by the way. I was building SLOs and I made an SLO that was working with a different Redis cluster. And then I created a distributed Redis cluster that's running on 4 different GKE clusters. And it's running on 2 different regions that are pretty far apart, west and central. And this is where I started seeing the latency. If I move back to the old model of just using memory store or something else, then the latency disappears. This is how I was able to identify it, but it just makes for a good demo, so I left it in the demo. All right, I have talked for way too long. I want to see what other people have any questions or not. So at this point, we can switch to the Q&A. And again, if you have other questions, please keep asking in the chat. All right, so I'm gonna first read these questions. All right, so Dheeraj, you asked, is ASM the same as managed Istio option that is available while provisioning a GKE cluster? So what used to be managed Istio is now ASM. Is that a fair assumption? Yes, in short, it is. There was, for those of you who may not know, I'll just give a quick history lesson. So we had something called the Istio add-on on GKE. And it only worked on GKE, and it was a way for you to either check a box or make an API call while you were creating a GKE cluster on GCP that would install open source Istio. It was an opinionated Istio implementation, but it installed it. That was a beta feature of GKE. We worked with the GKE team to just make installation of Istio easier. That was the purpose of that. It remained in beta we will now be moving that to GA, and the GA version of that is essentially managed ASM. And then we started doing other things. The reason we don't call it Istio on GKE is because, first of all, it works outside of GKE. Secondly, the implementation is a little bit different. The API calls are a little bit different. So essentially, those things will kind of, the Istio on GKE, the add-on will migrate to ASM. I'm actually working with the engineering team, with the ASM engineering team, to automatically migrate everybody over to ASM. So if you are using Istio on GKE, you should have received an email mentioning that that particular feature will get promoted to GA with ASM. So either we will upgrade the cluster for you automatically, or we will send you instructions on how to do that. All right. Hopefully that answered your question. If not, please keep asking. David asks, can Anthos Service Mesh support services outside of GCP? And looks like Jonathan responded, yes, it can support workloads. And that is true. So if you type Anthos, if you Google Anthos Service Mesh supported features, if you just Google these 5 words, hopefully the first link, last time I did that, it was the first link, will tell you the supported features. In the supported features, there's a platform section that will tell you which platforms are supported, which runtimes are supported. I can tell you right now that obviously GKE is supported. All of the Anthos clusters, the Anthos first-party Google clusters, so these are opinionated GKE clusters on non-GCP environments. So Anthos on-prem, Anthos on bare metal, which is what I showed you in the demo, Anthos on Azure, Anthos on AWS are supported. And then also non-Anthos clusters, which are what we call attached clusters. And currently the support is for, I believe, for AKS and EKS. Again, don't quote me on that one, but that's where we are. All right, next question. Can I use third-party or open source telemetry solutions with the managed ASM, such as Prometheus or Grafana? Yes, absolutely you can. So everything I showed you in the demo is in the Google Cloud Console. But let's say you say, well, I'm already using Prometheus and Grafana. I have people, I've got everything just kind of tuned in the right way, but I just want to get away from managing Istio, and I want to move to manage ASM, but I want to keep my telemetry bits as they are. You can absolutely do that. We are exporting Prometheus specs, so as long as your collector can collect it. The only difference is that when you consume ASM the way I kind of showed you, everything is supported, right? So everything I showed you today is supported by Google, versus when you export just the export into a different solution, then that solution, whether it's an open source solution or a third-party solution, is not supported. So you get into the kind of this fractured support sort of a model where you have to kind of figure out, how to support that. Can I migrate my current Istio open source clusters to managed ASM? Absolutely. Again, if you go to Anthos Service Mesh documentation page, there is a tutorial or a document that shows you how you can migrate everything. A couple of patterns that we've seen. Anthos Service Mesh gets installed as another version or as another revision of Istio, so you can have both of them running, and then you can just migrate your services over to Anthos Service Mesh by just relabeling the namespaces. That's one way of doing that. Or probably a safer way, but maybe a little bit more complex way, is to actually create new clusters that are ASM. So your old clusters have Istio, newer clusters have ASM, and then you just simply migrate your load balancers over to the new one. The good part about that is that the cluster will be in this new composition, and you can easily roll back if there was a challenge, and you can have kind of these up at the same time for as much period of time as you're comfortable with. Last question, does ASM provide me with security-related information about my services and clusters? Absolutely. I'm actually planning on doing another Cloud Innovators Live that we will just focus on Zero Trust Network. How can you use ASM or maybe even Istio to give you a Zero Trust network? We didn't have time to kind of go into that, and I just wanted to be laser focused on kind of the value of ASM. But now that you have this, we do have dashboards that provide you with information like whether your services have MTLS enabled, strict MTLS, whether you have authorization policies, authentication policies, even binary authorization. So the idea of basically, are certain functions checked for every single service? You can do that at a fleet level, so you can see exactly what the service posture of your fleet is, or you can go individually at the individual service level as well. So hopefully, wait for a different Cloud Innovators Live to do that. Okay, any other questions? Any of the moderators? Those are the only questions I had so far. No last minute questions. Okay, well then we can give some time back, maybe 15 minutes back to everybody. So again, thank you so much for joining us. Hopefully this was useful. You can learn more about the upcoming Google Cloud Innovators Live. There should be a link coming up shortly here, and that'll tell you what are some of the future sessions coming up. Like I said, I'm planning on doing one for how do you use Service Mesh specifically for security, but there's some other cool ones coming too. Thank you for joining, and we'll see you in the next one.